Everything else except for that periodic table is off. Do that. I just want to see how we do here. You may write the symbol instead of the name for the other of the 11 through 20. Okay, so you don't have to write the complete name there, but you do at the top if it asks for it, of course. Okay, so do not turn it over until everyone has it, so I can set the timer. I want to make sure that you have 5 minutes to work on this only. You do have your periodic table, which is going to be a great help. And then once you finish, if you would, turn in your notebook to where we last left off with the ionic bonds. Right there. Is everybody ready? Good. Remember that you remember the rules on this as far as remember the rules when it comes to quizzes and tests. Okay, make sure that you're don't jeopardize your integrity for this little 10% of a grade. Okay, so we're gonna get 5 minutes. Hold on. 5 minutes. I'll put the timer up here so you can see it, and you may begin. Pencils down. Let's get this up. Okay. It looks to me from what I'm looking at that we are ready to move on. You guys are showing great understanding of quite a bit. The one thing that I want to I guess reiterate and reteach or just continue to remind us of is that reactivity. Okay, the things that are the most reactive, the things that we know are very reactive. And what are those things that are most reactive? What group is most reactive? Group what? One, which are the alkali metals. Okay, group one. And why are they so upset? One electron in that outer shell, so they're kind of like just a little bit angry because they're so close to having that full outer shell. And which other one then, which other group then would be reactive, if that's the case? Group 2 is reactive, but not quite as reactive as 1. Which other group is very reactive? 17, and they're called the halogens. Excellent. Excellent. And they are angry, if you would, because they are so close to a full outer shell as well, right? Okay, so that's exactly where we're going with this. We're gonna go back in our notes on ionic bonds. Okay, so we have our notes on ionic bonds. I made a chart yesterday that looks like this, that came straight from our notes. One of our students actually were creating the chart from those notes that were given to you. And so they took that and then put it into the chart. If this chart would be helpful, then use that. But what I really like is, let me see some notes here that are very clear. Yours are very clear here. Let me show off some of these. So these notes, I love the way that we're working our notes, making it colorful, big, bold. At the same time, very clear diagrams showing exactly what's going on here. Okay? We're going to prove this again in a minute. This being an important part of the cations or the anions. It doesn't have to be that elaborate. It could be just as simple where you're just identifying which groups are going to bond together ionically. This part's just as well. Whatever is clear for you. Okay? And one way that you can do that is by putting this into an organizer. Okay? So can you see which ones by the colors, which ones are going to bond? Group 1 and 17. Group 2 and group 13 and group 15. So let's use that. What I want you to do is I want you to give me an example of an ionic bond for each one of these. Okay? So give me an example. So how many examples am I asking for? 3. Very good. So give me one example for each one. Okay? Just out to the side or in your notes. Okay? So let's do that. No, you don't have to have the chart. I was just showing you one way that you could organize your data if you needed to. Ionic bonds. Ionic bonds. Okay, so I think by this time we should have at least one per table that we're going to share. Give me one ionic bond that you came up with from this table. So any ionic bond. What do you have? What do you think? Okay, sodium and chlorine. So they take the first one, the one that we've been working with the most. That's fine. That's fine. Sodium and chlorine, which makes sodium chloride, and that's exactly right. What groups do those come from? 1 and 17. Fantastic. Next group. Give me an ionic compound that comes from, not from group 1, but group 2. Beryllium and oxygen. I just so happen to have that one here from a student work last year. Beryllium oxide. Okay? Beryllium oxide. So we have 6 on the outside here, but I see a mistake here. Do you?
Yes.
How many should beryllium have on the outside? There you go. It should have only 2. Okay, so this year, whenever you're working on your atom art, your ionic bonds, you're going to have the appropriate number of electrons on that outer shell. And then, can you see these 2? They would be going over here to make 8. Okay, and you'd have beryllium oxide. Another one from group 2 that we talked about yesterday. Do you remember? And I said I was going to show you.
Yeah.
Which one was it? What? Magnesium and what? Oxygen. So magnesium oxide. It's going to look the same way as that beryllium oxide. Let's do this first as a balance. So for beryllium, what number is beryllium? What's the atomic number for beryllium? Anybody? 4. Okay, so how many electrons will I need for beryllium? 4. So I've got it empty. So how many protons does beryllium have? 4. There we go. And how many electrons does beryllium have? 4. Okay. So at this point, let me help it out. There we go. It should be balanced. We have our positive protons, our negative electrons. So everybody's observing up here. Okay? So, if I have, and all of my elements on the periodic table are balanced, they are neutrally balanced. What does beryllium want to do? Does it want to lose electrons or gain electrons? Which group is beryllium in? It's in group 2. So how close is it to one of our magic numbers and wanting to where it can be nice and stable? Losing 2 is easier than gaining how many? 6. Good. So I'm going to lose 2 electrons. Is it now more positive or is it more negative? It's more positive. So magnesium becomes a positive ion. What is that called? A cation. Okay? Alright, on the other hand, so at this time, that was magnesium, and we said that it becomes a positive ion, how many? 2 plus, right? Okay? And we said that it was going to bond with what? Oxygen. Oxygen's in group what? You have a periodic table in your notebook to use. What's that? 16. So how many valence electrons does it have? 6. Yes.
I thought we used to go. That was just a
I know, but we're now on like magnesium, which is in the same group as beryllium.
Still the same thing.
Yeah, so it's the same. It's going to be the same kind of compound. Okay, so here we go. How many protons do I need for oxygen?
8.
You sure? 8. How do you know? Atomic number. 1, side for the electrons? Each. 1, 2, 3, 4, 5, 6, 7, 8. I gotta help it out again. Okay, so I now have 8 and 8. How many electrons does it want to have in the outer shell?
10.
Okay, it wants to have 10 total. How many on the outer shell? 8. Okay, so it wants to have 10 total. So how many is it going to get from the magnesium? 2. Okay, so watch. So now we're adding electrons. We're adding 2 electrons. Is it more positive? Is it more negative? It's more negative. So we have a negative. We have a negative ion. And what is that called? Anion. Because onions make you cry. So here we have a cation. Cats are positive. And then oxygen we have over here. This is going to be anion. Okay? Together, what do you have? Magnesium oxide. Can you see why they bond? Okay? It makes sense, right? Can you see why can you see the attraction? One's negative, one's positive. Things of magnetism. Everybody needs to be looking up here. I know you're taking that as well. Think of magnetism. What attracts?
Opposites.
Opposites. Do you see the opposites?
Yeah.
Do you see this one's going to be positive? It has a positive charge. This one has a negative charge. So together, they're going to be held together with this ionic bond that holds them together like a magnet. Okay? It's a very strong bond. So let's look at this in action because, I mean, okay, magnesium oxide, magnesium and oxygen come together. How do they come together? And that's what this is going to be about. Can someone read for me what I need to? I haven't read this yet. It was about something about first aid and safety, fire, explosion data. I'm not sure exactly, but anyway, if somebody wants to look over this, you know, no, actually, if you could please, like, just look over it. Tell me if there's anything I need to be aware of before I do this. Oh, you go right ahead. I'm just going to set this up here.
Don't let it touch your skin or eyes.
Oh,
Don't ingest it.
okay. Don't ingest
Or
it.
inhale it.
Inhale it. Ingest it. So I can't eat it. But magnesium's in our foods, right?
Not magnesium oxide.
They got your heart.
Okay. So basically, you don't want to touch it. You don't want to, as safety. I'm wearing my glasses. I'm going to be wearing my gloves. I can't get it like that, so I'm going to use this. Now, it is in group 2. Now, what do we have to do with sodium? Do you remember sodium? Do you remember sodium?
Yes.
Well, I couldn't even bring that out. I couldn't even touch it at all. I couldn't even, it couldn't even come into contact with the air before it started to oxidize, before it started to change, before it started to react. Okay? So this is going to be different, yes?
It says if you inhale it, then you could stop breathing.
Well, just don't breathe. No, you're not going to inhale it. There you go. Okay, so this is oxygen. That's what that is. What does it take to make a flame or a combust? You need 3 things. You need oxygen, fuel, and heat. A heat source. So as long as you have those 3 things, you have a fire. Okay? So, can someone hit the lights? Whatever you do, do not, I want you to observe, but do not look at it. What?
Exactly. Observe, but don't look at it.
Yeah, exactly. Observe, but it's kind of like, can you see the sun?
No. Yeah. Yeah. But don't look. And you don't look.
I mean, you can see it, but you feel like, see it.
So it's like the sun. You don't stare at the sun, right?
So don't look at it.
Okay. So here we go. I have actually, this is a tray full of sand to we go. You
So
ready?
wait, can we look at it or not?
You kind of look at it, but you don't look at it directly. You ready?
Just to like stare.
Oxygen, magnesium. That's a chemical reaction. That's a chemical reaction between magnesium and oxygen. And what's left here, and I'll pass this around, but what's left here, not this, is this white stuff. And this white is the magnesium oxide. The magnesium had different properties than the magnesium oxide. The oxygen has different properties than the magnesium oxide. Okay? So, the magnesium oxide is not flammable. It's not reactive. It's quite, if you would, peaceful and stable. Okay? In that bond. So, I'll pass this around. Notice that it's white. So it changed colors as well from the reaction. We know that there are indications of a chemical reaction. And so I'll pass this around. I want you to just kind of look at it. There is a piece of magnesium that's still there. I'm just going to leave that in there so you can see. It's shiny, it's malleable, it's ductile, it conducts electricity, it's a metal. Magnesium oxide doesn't do any of those things. Okay? It's more of a powder. And it doesn't have any of those properties as before. Okay? So, I'm going to pass this around, and you can look at it. And we're going to then, this is actually, this is called the material safety and data sheet. This comes with all the chemicals, so that you know what precautions to take. You know what reacts with what. It gives a long list of the things that magnesium reacts with, so that I can make sure before I do something, right? If we'll get the lights back on. Thank you. Today, what we're going to do is we're going to be creating a couple of different things. Let's think of that magnesium and oxygen. It had properties before, and then it had properties after the reaction, right? So you're going to do the same thing using poetry. You're going to research an ionic bond. Any ionic bond. Was there another ionic bond from the 13th and 15th group that you had? Anybody have one from there? Bn. Okay, so boron and nitrogen. They form an ionic bond. Boron loses 3 electrons. Nitrogen picks them up. Okay? So, you might want to research, well, what is Bn? What properties does it have? And what I would choose to do is choose an ionic compound that actually has something cool, different, or interesting that you're interested in. And what I want you to do is to create a poem in 2 voices. Okay? Let's give some examples before we move on. I need some brave volunteers for this next one. Okay, for that. And you're going to read? Yeah, all right. Yeah, okay, here we go. You ready this? And Havana. Would you like to be cicadas, mayflies, water striders? Water striders? Okay. So if you would, Havana, if you'll come through here and stand on that side, and Jerez, if you'll stand over here, you're going to need to read up here. And this is Joyful Noises, poems for 2 voices. And I want you to see the style that is used, okay? So whenever the lines are straight across, both of you say it at the same time. Whenever one is above and you say it, then the other person, okay? So there's going to be times where only you speak, Therese, and this is where you speak only, and then we move back and forth, okay? This is the style that I want you to mimic and emulate whenever you're writing your poems your love poems of the ionic bonds, okay? So, let us begin. Water striders. Ready? Yeah.
Whenever we're asked if we walk upon water, we answer, of course, to be sure it's quiet too.
Same time.
Whenever we're asked,
Okay, same time. 1, 2, 3.
whenever we're asked if we walk on it often, we answer quite often, each day, all day. Should we be questioned on whether it's easy, we answer quite easy, a snap. It's
A cinch.
should we be told that it's truly a miracle, we reply, bolder that.
No, it's an exclamation point.
Bolder that.
There you go.
Rubbish.
Rubbish.
Nonsense. Whenever we're asked for instructions, we always say, come to the pound stage and do as we do. Put down one foot and then put down another. Resting upon the thin film on the surface. Believe me, there's no call at all to be done. As long as you are resolute and thankful that you, by the time, are a student, no matter how prudent, constitutionally. Don't ask me why.
Son from you. So what was that poem actually saying? What's it saying? Who's speaking? Two water striders, right? And what were they doing?
Trying to teach someone how to walk.
Teach someone how to walk on water.
And then they drown it.
And then they just sing. Okay, so that's what that one was about. Okay, thank you very much. Oh, sorry. Okay, I need 2 more volunteers. We're going to do 2 more. Anyone named Ben or, no, let's see, anybody? I will call on you. This is the water boatman. All right, come on up, Sheridan. And Savannah, come on up. Thank you for volunteering.
There's 2.